I'm looking at the code for this deceived brain thing. I feel like I've just found the instruction manual for how my brain lies to me. This isn't code, it's a confession. In a way, it is. It's a functional model of the brain's predictive processing. It doesn't lie, Chloe. It makes its best guess based on incomplete data and prior assumptions. This code beautifully illustrates that. Best guess? My brain guessing the length of that Müller-Lyer line is like me guessing how many drinks is a few. It's always wrong. Let's start with this illusion data array. It's a list of recipes for chaos. Exactly. Think of each object in that array as a controlled experiment. The name is the phenomenon. The params are the variables we can manipulate, and the draw function is the visual stimulus we present to the user's brain. It's exceptionally well organized. It separates the data from the rendering engine. Right, so in the Müller-Lyer object, we have a parameter for wing angle. In my brain, is there a tiny little slider labeled gullibility that this thing is cranking up? Not a slider, but a population of neurons. The wing angle parameter directly manipulates the stimulus that excites specific orientation-selective neurons in your primary visual cortex, V1. Acute angles, like the inward-facing wings, create more neuronal activity at the endpoints. The brain interprets this heightened activity as more length. The code's wing angle slider is in essence a dial for controlling the intensity of that specific neuronal over-stimulation. So my brain cells are getting way too excited by sharp corners. They're like cats with a laser pointer. Okay, what about the herring illusion? This one has a convergence slider. I moved it to 1 and it turned into the want illusion. The code is basically saying, do you want your straight lines to look like they're exploding or imploding? This feels like a setting for a panic attack.
That, by the way, doesn't work at the moment. So, yeah, it meant to, in the conversion situation, meant to do that, but that meant to be reverse and going from top to bottom. But you'll try to fix it.
From multiple senses. Hearing the pitch change as you see the visual parameter change solidifies the cause and effect relationship, making the interaction more intuitive. So it's not just a lie detector, it's a lie synthesizer. Okay, last thing. The whole operation is run by this JavaScript state object. It has keys like current illusion, params, reality check. This is my favorite part. The entire web page has a state of mind. Right now, my state is reality check equals true, is demo running equals false, audio enabled equals true. Sounds like a diagnosis. Patient is grounded in reality, not currently hallucinating, but is annoyingly listening to everything. Chloe, you've just hit on the core of cognitive neuroscience. We believe the brain operates in exactly the same way. It maintains a state, a constantly updated internal model of the world. What you see, what you hear, what you believe to be true, it's all part of your brain's state object. This code doesn't just show you illusions, it's a beautiful, simplified metaphor for the very architecture of consciousness. So what you're saying is, my brain is basically a web browser running some very old, very buggy JavaScript, and these illusions are just the console errors finally showing up on screen? Or your brain is running the most sophisticated predictive code in the known universe, and this elegant script just found a few of its most fascinating edge cases.
Okay, can we briefly go over the two first illusions that were already covered, but then covered the rest of them as well? So explain the illusion, explain how it works, what you meant to see or not see, and then what the metrics can be changed, so the sliders that can be manipulated and adjusted. So like in Gemini 2.5 Pro, generating this discussion between Chloe and Dr. Thorne. Let's change one of the voices.
You've convinced me my brain is just running a state object. Let's go through this rogues gallery of illusions in the illusion data array one by one. I want to know exactly how each of these is scamming me. An excellent plan, a systematic debriefing. Where shall we begin? Let's do a quick recap. First was Müller-Lyer, the one with the arrows. My brain insists the line with the inward-facing wings is shorter than the one with the outward-facing wings, even though the reality check button proves they're identical. Precisely. As we discussed, that's your brain misinterpreting the neuronal excitement caused by the acute angles of the wings as additional length. The wing angle and wing length sliders in the code let you directly control the intensity of those misleading cues. A smaller angle creates a stronger illusion. Right, it's a don't trust pointy things life lesson. Then we had the hearing illusion, which I call the exploding lines diagram. The two horizontal red lines are perfectly straight, but the background of radiating lines makes them look like they're bowing out. And as you cleverly discovered, the convergence slider can reverse that, turning it into the Wundt illusion, where they appear to bow inward. It's a perfect demonstration of orientation repulsion. Your visual system tries to differentiate the horizontal lines from the background, and in doing so, perceptually pushes their orientation away from the radials and create a curve that isn't there. Okay, recap's done. Now for the new stuff. Next on the list is the Poggendorff illusion. This one just feels mean. There's a red line that goes behind a big gray bar, and my brain can't figure out where it comes out the other side. It always looks misaligned. This is another fascinating case of your brain over-interpreting angles. When the diagonal line intersects the vertical edge of the gray bar, it forms an acute angle. Your V1 neurons tend to overestimate acute angles, effectively flattening them out in your perception. So your brain miscalculates the line's trajectory. It assumes the line is less steep than it truly is, so it perceives the exit point to be lower than it is. So my brain fails geometry, and the sliders let me fine-tune that failure. The bar width slider is basically the gossip slider. The longer the line is hidden, the more my brain makes up about where it went. And the line angle slider, as I make the line more horizontal, the illusion gets weaker. Exactly, because as the angle of intersection approaches 90 degrees, the acute angle overestimation bias disappears. You've just found the boundary conditions of the illusion. Okay, next, Kanizsa triangle. This is the ghost hunter's favorite. There is no triangle. It's just 3 black Pac-Men, but my brain sees a bright white triangle sitting on top of them that isn't even there. This is the principle of modal completion, a powerful aspect of Gestalt psychology. Your brain prefers to see whole, simple, closed objects. It sees 3 perfectly formed corners of a triangle and concludes the simplest explanation is that a solid white triangle is sitting here, occluding 3 black circles. It actually constructs the illusory contours of the triangle in your mind. The perception of it being brighter is your brain signaling that this is a foreground object. So my brain is a conspiracy theorist. Connect the dots. The triangle is real. The sliders for this are great. Pac-Man radius just changes the size of the evidence, but the Pac-Man mouth slider is the key. If I make the mouth angle too wide, the illusion vanishes. Because the corners are no longer convincing. You've removed the specific geometric cue that your brain uses to infer the presence of a corner. The illusion is robust, but not infinitely so. It needs sufficient evidence. It's a very picky ghost. Finally, we have the Ebbinghaus illusion. The 2 red circles that are the same size, but one looks tiny because it's surrounded by giants, and the other looks huge because its friends are all shrimps. You've described it perfectly. This is a classic example of size contrast, or what the text on the page calls the center of mass theory. Your brain doesn't judge an object's size in isolation. It judges it relative to its immediate context. The large surrounding circles create a frame of reference that makes the central circle seem smaller by comparison, and vice versa. And the single slider, context scale, is the peer pressure dial. I crank it one way, the big circles get bigger and the little ones get littler, and the illusion becomes undeniable. It's a visual model of how your perception of yourself changes depending on who you hang out with. A surprisingly profound analogy, Chloe. Yes, that slider directly manipulates the strength of the visual context, thereby manipulating the strength of the illusion. So, to sum up, my brain is a compulsive shape finisher, it's terrible with acute angles, and it judges everything based on the company it keeps. I'm not a mess, Dr. Thorne. I'm just running Buggy legacy firmware. It's not buggy, Chloe. It's optimized for a world that usually makes sense. This code is just a wonderful toolkit for finding the beautiful, predictable seams in that optimization.
Yeah, that video was brought to you by AI Studio Gemini 2.5 Pro Preview TTS, text-to-speech model. Can we do an extended review of each illusion type, but then explain the different parameters, the sliders that can be changed, and the reality check, and what is it we're meant to see? If we can give overall context for the illusion, any science behind it in regards to which part of the visual system is being mostly affected. I mean, speculation is fine in this regard. I don't think anyone actually knows how the brain really works. Everything we do on this channel is available on BioniChaos.com. Go check it out and let us know what you think. We redeployed the website. So it's all deployed. Here we have this using images from the website. So we have this biomedical, well, it's not biomedical, but it's art, a cognitive simulation. So you have to find, it's like a puzzle, but instead of moving the pieces, which you cannot do, you have to actually find the angle where you can view the image. Yeah, pretty basic stuff. I mean, you can break the image into gazillion more segments and not make them square, and then it will actually look like a 3D model of something where you would need to, yeah, obviously there's more to it, but I don't know how to improve it. If you have any ideas, let me know. Yeah, we have this shadow. It doesn't really work as expected. We have this shadow blister. Anyhow, it meant to show you this shadow effect. Essentially, yeah, where it looks like there's something funny going on with the shadow. Can't really replicate it with this. It's yeah, if I have any shadowy specialists listening to us, to let me know. So yeah, just a reminder, everything we do is available on BioniChaos.com. Go check it out, provide your feedback. It will really be helping us a lot. I'll see you next time. Bye.